Polynomial division. It's basically the same as long division, which you might remember from, well, primary school. Is it the first time you do long division? Where you want to rewrite the, when it was just numbers, we rewrote it as its divisor times quotient plus a remainder. Well, it's still true. AX is some function which is the divisor, QX is some function which is the quotient, RX is some function which is the remainder. So it's still the same idea. A couple of things to note. The degree of the remainder must always be less than the degree of the divisor. Because if it was the same or more, you could keep dividing. And QX and RX are unique, so they've got to be different functions. Because if they were the same, well, you could factorise it. Very, very old question now, 1998 HSC. But basically they're just asking us to find the quotient and the remainder when we're going to divide this polynomial by x squared plus 1. So we set it up the same as we did with long division. Important thing to remember is to include every term. So even though in the expression there is no x cubed term, we still write it in our division as 0x cubed. So it's like we have a column for each of the powers. And when you're dividing with polynomials, what you're actually dividing is the leading term into the leading term. So x squared is going into x to the power of 4. Okay, divide x to the power of 4 by x squared, we get x squared. So now we multiply that divisor by x squared and write it underneath. So we have x to the power of 4 plus x squared. We do a subtraction to get our remainder. The remainder in this case is minus 2x squared. But the degree of the remainder is the same in this case as the degree of the divisor, so we can keep going. X squared into minus 2x squared, minus 2. Multiply out, we get minus 2x squared minus 2. You'll notice I brought down the other terms that we haven't used yet, so the naught x and the plus 1. Work out our remainder. 1 minus minus 2 is 3. The degree of the remainder now is 0, which is less than the degree of the divisor, so that's where we stop. So we want to make sure we answer the question. The question said find the quotient, so the quotient is x squared minus 2, and the remainder is just 3. So the first part of the question, perform this division. Let's set it up again. X squared into 2x to the power of 4 goes 2x squared times, multiply out, work out our remainder, which in this case is minus 4x cubed plus 10x squared. Well, plus 2x minus 3 when I bring those terms down as well. We can keep going because that's order 3. The divisor is order 2. So x squared into minus 4x cubed, minus 4x. Multiply that one out. Work out our remainder, minus 2x squared plus 6x. Well, bring the minus 3 down that we haven't used yet. And we can keep going again because that's of order 2. Our divisor's of order 2. So x squared into minus 2x squared goes minus 2. Multiply out, find our remainder, and that's where we can stop because the degree of the remainder is now 0 and the degree of our divisor is 2, so we can stop there. Well, we've answered the question because it says divide it. We've done it. So part 2, now they want us to write it out like that algorithm before, where it's divisor times quotient plus the remainder. So from what we've just worked out, our polynomial could be rewritten as that, x squared minus 3x plus 1 times 2x squared minus 4x minus 2, and then minus 1. Back to the graphing of polynomials then. This idea, if you've got a polynomial on top of a polynomial, that sort of function you want to draw. If you do a polynomial division on it, you could rewrite that as the quotient plus the remainder over the divisor. But when it's in that format, it tells you a lot of information. The bottom of the fraction can't equal 0. So we solve the divisor to find any vertical asymptotes. The quotient will turn out to be the asymptote. Oblique, horizontal, just depends on what that function is. And the top of the fraction, that remainder, we use that to find if the curve cuts those horizontal or oblique asymptotes. So let's do this one as an example. Y equals x plus 8x on x squared minus 9. So the division's already been done for us. Okay, vertical asymptotes, bottom of the fraction can't equal 0. So we know we've got x is plus or minus 3. Let's plot those in. 2 vertical asymptotes. We, in this case, have an oblique asymptote because the quotient ended up being x. So y equals x. Let's plot that one in. There it is, y equals x. In this case, the curve will meet the asymptote because it is possible for 8x to equal 0. It'll happen at x equals 0. So we know our curve is going to go through the origin, which happens to lie on that asymptote. I can now complete the sketch, remembering the curve has to bend towards the asymptote and things like that, and we get our curve. So 10C, polynomial division.